Hey guys, this is our lesson video for 2.8. I'm on the retreat right now. You are in class. Hopefully you have started by just trying this warm-up. If you haven't yet tried the warm-up, go ahead and try the warm-up. I'm going to go through the problems, then we're going to do some notes and a little bit of practice, and the rest of the class time you will have to do the homework. Okay, so I'm assuming you've tried these. Let's go over them. F of g of x. So g of x is going inside the input of f of x, so this would become x plus 1 to the power of 3. Okay, we could simplify this out. It's okay if you didn't, but if you multiply out x plus 1 times x plus 1 times x plus 1, this would simplify that composite function, okay? F of x. Okay, so it's the same function going into itself, right? So it's, let's do 1. So x to the third is becoming the input of x to the third, and that is becoming the input of x to the third. So what we have here is 3 times 3 times 3. This is x to the 27th, okay? Make sure again, like when you see these open circles, that's a composition, not multiplication. Okay. Now we're doing the same, but with values. H of g of 2. So let's go find g of 2. G of 2 equals 2 plus 1. That is 3. So h of 3 is 2 times 3 squared plus 1. That is 2 times 9 plus 1. That is 19. F of g of h of 0. H of 0 is 2 times 0 squared plus 1. That's just 1. So g of 1 is 1 plus 1. That's 2. And then f of 2 is 2 to the third power. That is 8. So starting on that inside and working my way outside is how I like to solve these. Okay? Hopefully that's pretty clear. All right, that's the warm-up done. Those are the answers. Now I want you to get your toolkit out. This is toolkit 2.8. We're going to jump straight into the notes, and then we'll do some practice problems. Okay? All right, so toolkit 2.8, inverse functions. We're starting with one-to-one functions. What does that mean for a function to be one-to-one? Well, let's talk about functions in general, right? So what you've seen in the past, you might have seen something like this. We have A, we have B, and we have certain inputs. Let's say we have 1, 3, 4, right? We have certain outputs, maybe 2, -1, 0. And what you've seen before is maybe something like this, where 1 goes to 2, and maybe 3 goes to 2, and then 4 goes to 0. And this is a function because each input has only one output, right? That's what made it a function. Each input had only one output. What one-to-one functions, unfortunately, this is not a one-to-one function. Do you know why? Well, because both 1 goes to 2 and 3 goes to 2, this is not one-to-one. Okay, so let me give you an example of what something that could be one-to-one. One-to-one might be something very, very similar. We can have the same 1, 3, 4, 2, -1, 0. But this time, they do not go to the same output. Each input has a unique output. Okay, you see the difference? So here, both 1 and 3 went to 2, had an output of 2, but here every input has a unique output. So each input has a unique output, and each output has a unique input. Okay. here is some other notation. We can say that no two different inputs will have the same output. That's what this is saying right here. So if x1 is not equal to x2, that these are two different numbers, two different values, it is not possible for them to have the same output. Okay? No two inputs can have the same output. It's that easy. No two inputs can have the same output. Okay, so this is what it means to be 1, 2, 1. No two inputs can have the same output. Okay? All right, so let's look at how we test for this. Well, one way we can test is you can look at if you're given the elements, right? Then you can see, oh, okay, our two inputs going to the same output. That's one way you can test. The other way you can test is called the horizontal line test. Now, we've seen the vertical line test before. Let's review that for a second. We have let's say we have a parabola, and we're looking for vertical line test. This is testing whether it's a function, right? And it says any vertical line can intersect function no more than once, right? That's vertical line test. So this passes the vertical line test. This is a function, right? You see that like every vertical line, no vertical line would intersect this more than once. It passes, right? But then we have, so let's just show that here. Let's take that same parabola and let's try what's called the horizontal line test. Horizontal line test. This tests if it is 1-to-1. This also tests if it's invertible, which we'll be talking about in just a second. Invertible, that means the inverse is a function. Again, we'll be talking about the inverse in just a moment, okay? This is what it's used for. And it's the same as vertical line test, except instead of vertical line, it's a horizontal line. Any horizontal line can intersect f no more than once. Okay, so here we draw a horizontal line. We're seeing that we are intersecting it twice. So what you're seeing is that two different inputs, right? Whatever this is x2 and x1. Well, f of x1 is equaling f of x2. The output at x1 is equaling the output of x2. So therefore, this is not 1-to-1. Okay, because remember that's the rule. For it to be 1-to-1, the no two inputs can have the same output. Okay, so we know vertical line test. We're familiar with that horizontal line test. You check, you draw. You're imagining you're drawing lots and lots of horizontal lines. And you're seeing, is there anywhere that I'm intersecting the function more than once? If so, it is not 1-to-1. If everywhere it only intersects it one time, that is 1-to-1. And that means it's invertible. Again, we'll talk about invertible now. Okay. So what is the inverse of a function? Okay, inverse of a function, let's think about that. Let's do a table. Okay, let's do a table. We have x and we have f of x. And maybe we have 1, 3, 8, and 5, 7, -10. When we evaluate the function and we find something like f of 1, we find the output to be 5, right? We have, this is our input, right? And this is our output of f, right? Well, when we take the inverse, what we do is we switch those. So the notation is, it looks like f to the power of -1. But this does not mean 1 over f. This means inverse of f. That makes what was formerly the output is now the input, and what was formerly the input is now the output. Okay, so f of 1 was 5, right? F of 3 is 7, f of 8 is -10. But the inverse function of 5 is 1. The inverse function of 7 is 3. Okay, so instead of going from x to f of x, we're going from f of x to x. That's how the inverse works. We're switching. We switch input and output. When we do this, if f of x has domain A and range B, the inverse has domain B and range A. So the domain and range are switched. That makes sense, right? Because we're changing what is the input to be the output of the original. Well, that's our new domain. And our new range is what was formerly the input, right? We're just switching the output and the input. So we're switching domain and range. So we've talked about finding specific values. You can think of it like you're looking at the y value and finding the x value. You can think of it like that. Like one more way to think about it is f of x is x to y. The inverse of f of x is y to x. Okay? So, well, how do we find this? There's a few more things I want to cover here. How do we find them? How do you get the inverse function? This is really important. So we're going to do down here, I'm going to split this up. On the left side, we're going to find it algebraically. On the right side, we'll find it graphically. So this is algebraically, and this is graphically. So algebraically, it's 3 steps. Okay, first thing you're going to do is you're going to write f of x as y. So you're going to change f of x to be y. Then you're going to switch x and y, and then 3, you're going to solve for y. Okay, let's do an example. So let's say we have f of x equals x to the 5th minus 3 over 2. Okay, first step is you got to write that f of x is y. Okay, pretty easy, right? We're just going to say, okay, y equals x to the 5th minus 3 over 2. Then you're going to switch x and y. So this is step 1. Step 2, we're going to switch them. So we're going to have now x equals y to the 5th minus 3 over 2. Then in step 3, we're going to solve that for y. Okay, so we're going to get y alone. So I'm going to multiply both sides by 2. We're going to have 2x equals y to the 5th minus 3. I'm going to add 3 to both sides. We're going to 2x plus 3 equals y to the fifth. And then last step, I have to undo this 5, so I could take the fifth root of both sides. So fifth root here and fifth root here. That will undo, and we'll have the fifth root of 2x plus 3 equals y. This is my inverse. So the inverse of f of x is equal to the fifth root of 2x plus 3. Okay? That's the inverse. Does that make sense? Hopefully that makes sense. So one more time. Change f of x to y, switch x and y, solve for y. Whatever you get at the end, that's your inverse. So something important about inverse functions, which I'll write up here, is an important trait that this is called the inverse function property. And that says that if you compose them together, you remember function composition from right here? What happens if we compose them together? If we take the original function and plug it in to the inverse, what happens? And if likewise, if we take the inverse and plug it in for the original, what happens? Well, it turns out that this always ends up with x at the end. So if you were to take this inverse, fifth root of 2x plus 3, and plug it in here, x to the fifth minus 3 over 2, you would get x at the end of it. So we can use this property to verify. In case that's not clear, I will do that right now for this example. Uh-oh. Still having issues. Here we go. There we go. Okay, so for this example, my f of x was x to the fifth minus 3 over 2. My inverse was the fifth root of 2x plus 3. So I'm going to do f of the inverse, and that's going to be the fifth root of 2x plus 3 all to the fifth power minus 3 over 2. That becomes just 2x plus 3 minus 3 over 2. That's just 2x over 2, which is just x. So that's an example of me using this property to verify that my inverse was correct. If you plug the inverse in for the input of the original function, you'll just get x. Okay, we're doing good. How about graphically? So when we find the inverse graphically, let's say we have this as f. The function is reflected over the line y equals x. So this is y equals x. My inverse would be, right, roughly, gets to the perfect, right here. It would be reflected over y equals x. So you can do that if you have a question, or I think a much simpler way, the easy way, is get coordinates of f and switch x and y. So let's say let's look at a little table here. Let's say you know in f that 0, 1 is a coordinate. That means in the inverse that 1, 0 must be a coordinate. Or if you know that -2, -1 is a coordinate in f, well, that means -1, comma -2 is a coordinate in the inverse. Okay. All right. We're nearly there. There's a couple more problems I want to show you before you get to the homework. To turn this paper over, I will have written this problem down, but I want to do one rational. So this is finding the inverse of a rational function. This will be on your paper. You're going to see these in your homework, and I want to make sure you're ready for them. So let's say we have f of x equals 2x plus 3 over x minus 1. This is a rational function. We have a fraction. We have an equation, an expression on top and an expression on bottom. The steps are the same, right? So we're going to write it as y equals 2x plus 3 over x minus 1, and then we're going to do the switcheroo, right? X equals 2y plus 3 over y minus 1. This is kind of the tricky part. This is tricky mainly just because of the algebra. We have to get y alone, right? We need from here, get y alone. How do we do that? What you're going to do is we're going to get rid of this denominator. So we're going to multiply both sides by y minus 1, both sides. So we're going to have parentheses y minus 1 x equals 2y plus 3. You follow me there? We just multiply this side by y minus 1 and this side by y minus 1. That cancels here, so we end up here. Then we're going to multiply this through. We're going to have yx minus x equals 2y plus 3. Okay? Then we're going to group the terms. So any term with a y in it, we're going to move that to the left, everything else to the right. Okay, does that make sense? Everything with a y term in it, move that to the left, everything else to the right. So we can have, we're going to have yx minus 2y equals x plus 3. So I'm moving this 2y to the left, and I'm adding an x both sides. All right, now I've got my y terms on one side, everything else on the other. We're then going to factor out the y. Y comes out, x minus 2 equals x plus 3. And then my last step, to get that y alone, we're nearly there, just divide by x minus 2 both sides. This cancels, right? So just y equals x plus 3 over x minus 2, and that is your inverse. Okay, so I'm going to recap that just to make sure you understand. When you get a rational function that you want to invert, normal stuff, you change it to y, you change the x and the y's. To get the y alone, we multiply it by its denominator, move that over, multiply it through, group the terms, anything with a y on one side, anything without a y on the right side, factor out the y, then divide by that product. That's it. All right, guys, well done. We're homework time now, and I will see you next week. Good job.